Good morning, and today we'll be looking at the equation of the straight line in the form y minus b equals m bracket x minus a. You should be familiar with this version of the straight line equation from National 5. It is the very useful form that you use to be able to find the equation of the straight line. Okay, so the equation of the straight line can also be written in the form y minus b equals m bracket x minus a, where m is the gradient and ab is a point that it passes through. So this one is very useful because you can use any point that it passes through. It doesn't have to be where it crosses the y-axis as it would be for the other equation, which is y equals mx plus c. So this one's a very useful one to be able to find the equation of the straight line. This form is useful to find the equation of a straight line if given the gradient. Now you may be given the gradient or you may have to work out the gradient and any coordinate that the line passes through, just as I said. So it's very useful to find the equation of the straight line using the y minus b equals m bracket x minus a formula. That's the formula that you always use to find the equation of a straight line. Okay. The only reason that you wouldn't use this formula would be if it is a vertical or a horizontal line, in which case it would be an x equals a number or a y equals a number, or if you did see where it crossed the y-axis, in which case you could use a simpler equation y equals mx plus c. But this one's very useful if you have any coordinate that it passes through. Okay, that it doesn't have to be the coordinate that's on the y-axis. So here's an example. Find the equation of the line with the gradient 2/3 passing through the coordinate 4 minus 2. So we've got the gradient and we have our coordinate. Remember, we'll take that as being the a and the b from the equation. So the a is 4 and the b is negative 2. So y minus b equals m bracket x minus a. Substitute in your gradient, your a and your b. Watch out for double negatives. Y minus minus 2 equals 2/3 x minus 4. Now you will have seen a little bit of this on the National 5 course where the gradient is a fraction, but you will see it more often now in the higher course. There is a very specific way that you deal with the fraction that's the gradient. And what you do not do is multiply the bracket by that fraction. The first thing you do is get rid of the fraction by taking the denominator over to the left-hand side. Okay, so we'll tidy up our double negative on the left-hand side as well. And then the next step will be to get rid of the fraction. So we take the 3, which is the denominator on the right-hand side, and bring it over to the left-hand side, and it makes a multiply on the left hand side. So the 3 that is the denominator, it's a divide on the right hand side, becomes a times on the left, and you must make sure you multiply everything by that 3. So we now have 3y plus 3 times 2, which is 6, and then we're left with the top of the fraction, which is now 2, and that's just the whole number 2. So that 2 gets written as 2 times the bracket. Okay, so now it's a much simpler equation to be able to rearrange because we've got rid of the fraction. Okay, so we now multiply out our bracket on the right hand side. 2x take away 8. And now we have to decide how we're going to bring these two constants together. So we have to bring either the 6 onto the right to join the negative 8, or the negative 8 onto the left to join the 6, and we can decide which way we want to do that. Okay, so I brought the 6 over to the right hand side, and then I have a negative 8 take away a further 6, which is where the negative 14 comes from. Okay, now that's actually a format that you can leave your answer in. That's absolutely fine. You don't have to bring it back to y equals mx plus c. You don't have to do anything like that. Here are some acceptable versions of the form, and the format for the equation to leave your answer. You will see a variety of these in the back of the book when you're answering your questions. So that's the version that we have there, where we just brought that over and we left it. The rule is you have to bring your constants over to the left or to the right, and then you can just leave it like that, unless it asks you specifically to leave it in a different format. So other versions would be to have the 2x there, the 3y can be brought over, which is why it's a negative 3y. If the 14 was on the other side, it would be a positive 14. The 2x brought onto that side, the 14 brought over to the 3y is that version there. Everything brought onto the same side. Now we're going to be doing a little bit of work on this. When everything's on the same side and the right hand side is equal to 0, we call that the general equation of the straight line, which is what we had been doing in the last exercise. Just remember, if you are doing that, and specifically if it asks you to write your answer in the general equation of the straight line, you bring everything to the side that makes the x's positive. You always start with a positive x, and then everything else is brought into that same side. Okay? They're all acceptable unless you're told otherwise. Okay, here's one with a little bit more work to do to get it ready. Find the equation of the line passing through these 2 points. So remember, for an equation of a line, we need 2 things. We need the gradient and we need a point. We don't have the gradient, but we can work out the gradient. So we'll do that to begin with. Okay, so I've written the 2 coordinates down, labelled them appropriately, and I'm going to use the gradient formula y2 minus y1 equal over x2 minus x1. Okay, so we substitute the numbers in. What's your double negative there? So 3 minus minus 2 over 4 minus 3. Okay, so the 3 plus 2 is 5, 4 minus 3 is 1. Don't leave your answer as 5 over 1. If you ever have a fraction that can be simplified, you must simplify it or you will lose marks. So obviously that is just the whole number 5. So we use the gradient 5 and then we have a choice. So equation of the line through, and I've written here 4, 3 with the gradient 5, but we could have easily used the other coordinate, 3, negative 2. Why do you think I've chosen to use 4, 3 instead of 3, negative 2? The only reason I've chosen to use 4, 3 is simply because the numbers are both positive. Avoid negatives if you can. If you're not comfortable using negatives, then you would obviously choose to go for the positive, but both of those coordinates would give you the same answer. Okay, so remember your A is 4, your B is 3, and your gradient is 5. So your A is 4, your B is 3, and your gradient is 5. So y minus your B, which is 3, equals your gradient, which is 5, x minus your 4. Multiply the brackets, so it's a little bit simpler this time. There was no fraction for the gradient. Multiply the brackets and then bring that over to the right, or the minus 20 over to the left. So I brought the minus 3 over to the right. Y equals 5x minus 20, and that would be a plus 3 on that side. Minus 20 plus 3 is where the minus 17 comes from. Okay, so we had to find the gradient first of all because we weren't given the gradient. So as long as we're given information to find the gradient, then we can find the gradient. And then once we do, we choose which one of the points would be appropriate, and we put them into the y minus b equals m bracket x minus a formula. And make sure you're able to just say that formula as easily as I can. Y minus b equals m bracket x minus a. You know it off by heart and you can say it and use it easily. Okay, so we're now going to do the selected questions from exercise 1G. And let your teacher know if you're having any problems with any of the questions, and good luck and take care. Bye.